So how many of you have worked with object-oriented programming before with like classes? Okay, so 2 out of 3. All right, so I'm gonna be talking about how that type of thing works in JavaScript because it's a little different. What languages did you guys work with? Java and
I thought JavaScript. I thought it was.
It uses prototypical inheritance instead of classes. So it's just a little different. Yeah, but yes, you can do object-oriented JavaScript, but it has some subtle differences from doing object-oriented programming in other languages. All right. So, JavaScript objects, you guys have used them. We use them every day. They are basically just key value pair data types, and they are the base type for prototypical inheritance. And what that means is that every data type in JavaScript is based on objects. Booleans based on objects, strings based on objects, arrays based on objects. Everything is based on objects. So prototypical inheritance is how JavaScript addresses object-oriented program. And basically, it's a way for objects to inherit properties from other objects. Okay. And I need to, just for my own sake, I need to just do, and okay. All right, so let's talk a little bit more about JavaScript objects. They're described on the MDN site as a dynamic bag of properties. And sometimes we use bag if we mean that it's not ordered, right? So you think of an array as something that's ordered, but objects, there's no inherent order to the properties. You just take a key value pair and you throw it in the bag. All right, keys are always strings. Property values can be any data type. So it could be a number, an array, a function, a regex, whatever. But the keys are always strings. I want to put a slide in here that I didn't before, but I just want to talk a little bit about the keys being strings, and I'll do that in the REPL. So I'm going to make an object. Okay, and so Mochi, I can do mochi.name. That's dot notation, right? I can also do mochi name like that. That's bracket notation. So I have dot notation, I have bracket notation. Sometimes you need to use bracket notation. For example, if I said mochi, if I wanted to say mochi 1, this was more like for arrays, but for whatever reason, I wanted my key to be 1. That key it's going to stringify that 1, by the way. And so now if I say mochi 1 equals, oops, number 1. So now if I do mochi 1 like this, I can get that, but I can't do mochi.1. That's not acceptable. Keys, the keys have to be strings, and the only way I can actually make it into a string, if it starts with a number, is by putting it in the bracket notation. So if you look at Mochi, notice that is the string 1 and not the number 1 that it did there. Another reason you might want to use bracket notation, so let's look at Mochi again. What if I didn't know what the key was? And here's where I wish I'd made a slide, because this is going to be a little abstract and I'm not necessarily going to be able to come up with an example. But let's say the key, I have a variable called key, and it's the string species. And I want to get the Mochi value that's associated with whatever property is stored in key. Does that make sense? So if I do mochi.key, what's that going to do? I see you shaking your head, Celeste. Yeah, so when you use dot notation, it actually stringifies whatever is after the dot. That's why I can do mochi.species without having to put like quotes around it, right? But if I do mochi.key, it's just going to give me undefined. There's no property associated with the value key. That's where I have to use bracket notation. Now, and remember, when I did bracket notation before, I had to actually make it a string here. If I do this, what's going to happen? It's going to look for a variable named species, and it's not going to find it. Okay, so just some subtleties of dot versus bracket notation there. That will get a slide later. Oh, right, and then this is this weird thing that I do not enjoy. All right. Okay, so that's our foundation in objects. Now let's talk about prototypical inheritance, which is sort of the key part of this lecture. So I want to talk about the differences between classes and prototypes. So when you are making a class, like in Java or in Python or in other languages, you actually make a class, you make instances of that class, and you're actually kind of making your own data type. And you can make your own data type based on another class, but you don't have to. You can just invent your own data type from the ground up. Using prototypes, everything, and so you have instances. So if I make a class called cat, I have instances of that cat class. In JavaScript, everything is an instance of an object. Object is at the top of the prototype chain. And so every new data type that you make in JavaScript is based off of object. And we call it a prototype. Absolutely. So is a Boolean. So is a string. Yeah, we're going to talk a little bit more about instance methods, but yeah, yes. If you are using a method, doing something dot something else, you are doing a method on that instance. But you can also have, maybe you call them prototype methods. I would call it a class method in another language, which is like object.keys. You're not putting an actual object here. You're putting the literal object type. And then you pass it an object. I would call that a class method, but it might be called a prototype method in JavaScript. I'm not sure. Whereas an instance method would be mochi.toString. All right, so let's talk about the prototype chain. So if I make a regular expression, we know that's a regular expression because it's bound by forward slashes. And then I ask what its prototype is. And this is how you ask what its prototype is in Node. You do re.dunder, which is double underscore, dunder proto. So let's actually do this. What does that regular expression mean?
All of the A's.
Any number of A's, 0 or more. 0 or more A's, that's what the star means. It's like, what is the prototype? It's a regular expression. What's next in the prototype chain? It's an object. What's next in the prototype chain? Nothing, we've reached the end. Let's make another thing. So I'm going to say, well, what if we do mochi? What do you think that's going to be? An object. This. Null, we've reached the end. Object is as far as it goes. Object is always the end of the prototype chain. So mochi doesn't get it. So re here gets both properties of a regular expression and properties of an object. Mochi just gets properties of an object. If I say nums is an array, I don't love the way Node does this, but now an object. Questions about this prototype chain? Well, give me a minute. Okay. Yeah. No, it's a totally legit question, but hopefully I'll answer that. All right, there's no way I can get to this with a keyboard shortcut. Something's got to change. Okay, so remember that tab we discovered the other day? So we can see where these methods come from. So if we look, and we do an re dot, and you do this tab, it actually gives you, okay, so this is from object. And this is from regular expression. Honestly, I'm not sure why this is in its own section. That's something I'm going to have to look up. But if we do nums, this is from object, and this is from array. So if I do nums dot sort, it looks at the prototype chain, and it's like, did you find a sort here? You did? Okay, then you can stop here. Don't even look at object. Let's look for a toString. Is there a toString here? There is not, so now I'm going to look at object. So the toString is the toString from object. If I do, let's see, has own property. We'll talk about has own property in a minute. Where is that one coming from? That one's coming from object.
So those be considered, are those all instance methods?
Some of them are instance methods. Some of them are not methods at all. They're just properties. For example, if I do nums.length, that is not a method. That's a property. Yeah. Questions on this? We'll talk about that in a future slide. Yeah. And then if I do something like awesome sauce, that's just going to be undefined because it doesn't find that in this case in the regular expression, and it doesn't find it in the object. All right. Kelsey, your wish is my demand. Has own property. So it's used to tell whether the object inherits the property or whether it is actually the object's own property. So here, like I can make Cisco. Cisco features heavily in this lecture. So I'm going to make Cisco, and actually, oh, well, all right, that's fine. And if I do Cisco has own property name, that's true. But if I do Cisco has own property toString, that's false. Cisco.toString exists, but it is not Cisco's own property. It's inherited from its prototype chain. Yes, because Cisco's prototype chain, if we look at it, Cisco's prototype chain is pretty short, just has object. Yeah.
Since Cisco is an object, isn't it? Prototype. I mean, so you created Cisco. Right?
Cisco is an instance of an object. Yeah. So, but if you are thinking about what's on the prototype chain, it's going to be Cisco, then object.
Oh, I see.
And so Cisco is here, and then object is here.
So then you do Cisco. Done. It's not a single.
Exactly. Yeah. Yeah, and it's the same way that RE is an instance of a regular expression. RE is not regular expression, the class or the prototype. It's an instance. Yeah. And nums is an instance of an array. Can you overwrite inherited methods? You guys are asking awesome questions that are covered in future slides. Yes. In fact, you're basically just like pushing me along in this lecture. Okay, so property shadowing. All right, so now I have Cisco. And here I was smart enough to make Cisco a var, because I'm actually going to have to Control C. Can I do? I think Cisco's a const, and that's it. I think I have to get out of here. Okay, so here I have Cisco, and if I do a Cisco.toString, I don't like what I get. That's not Cisco's essence, right? So I'm going to override it. I'm going to say Cisco toString is a new function that returns meow, I'm Cisco. So now if I do Cisco.toString, I get meow, I'm Cisco.
Is it like forever?
Yes, forever for the life of Cisco. But I haven't changed other objects. Mochi doesn't have a special toString.
So you just changed that. Just changed the definition.
I changed the definition of this method on Cisco. I did property shadowing on Cisco. And notice that if you look at Cisco after this goes away, now Cisco has another property called toString. And what do you guys think?
No longer inherit.
Okay.
Is there a has property?
Oh, has property? No, I think has property is that's the equivalent of has property.
I don't understand.
So if you have something that's defined, then the property exists. Where if I said mochi.Kelsey, so Mochi does not have a property called Kelsey, but Mochi does have a property called toString. All right. Let's make new prototypes. You can have a constructor. So notice this is function. It is just like any other function. I have a hint that I'm making a prototype in that I gave it a capital letter. Prototypes generally have capital letters. That's a convention, strong convention. In other languages, classes have capital letters. Yeah.
Oh, just run back one second. Just run
Yeah, so the question was, would you define property shadowing as redefining an inherited property? And the answer is yes. Okay, so we have a constructor. And again, you know, nothing's really distinguishing this from a function that you might write otherwise, except for the fact that we gave our function a capital letter name, and we're using this. I'll get to this in a minute, but let's just run this code. Okay, so now we have pet. Great. And I will be smart and not include the const. Okay, so now I have Cisco, and Cisco now is a pet. Cisco proto, pet. Pet is based on object. And again, I made Cisco by saying Cisco equals new pet. I didn't just call the function. I actually said new. That's how I'm making Cisco. It's a constructor function. All right, let's dig into this a little bit. Oh, apparently I wanted to dig into Cisco a little bit. So Cisco now is a pet with a name, a species, and an age. So I can do Cisco.age. It'll give me Cisco's age. If I do Cisco.favorite food, that's undefined. Cisco only has this stuff from object and this stuff from pet. Okay, so yeah, so now I want to talk about this. This in JavaScript. I don't know if you guys have heard this quote, but I'm probably paraphrasing, but it's basically like, when I'm writing JavaScript, I always want to say F this, but I never know what this is, right? This in JavaScript. So I have a link to MDN. So this, so you have a global context, you have a function context, and then you have, we're still in function context, and then we have as an object method, and that's what we're talking about now. As an object method, it's set to the object the method is called on. So, yeah, so for constructors, it is the object being constructed. So if we go back to the terminal and we look at our constructor here, this refers to whatever object you are constructing. So when I say Cisco equals new pet, Cisco is the this here. And remember how I was talking about how methods, in our functions lecture, we talked about how methods have access to all of the data about the object? That's how they get it, by using this. So let's look into that a little bit. Oh, okay. Well, okay. Well, we're going to look into that in a minute. So I can also make prototype properties. And these are things that can be, that everything is going to inherit regardless. So if I say, I'm changing the pet prototype now. The pet prototype is now different. So if I do Cisco.leg count, I actually get 4. Cisco does Cisco have own property leg count? No, the leg count is on pet.prototype. It's not on Cisco. Because when I defined Cisco, I said I actually want Cisco.name to equal name. But here, Cisco.leg count, Cisco doesn't have its own property leg count. So now I've got 3 blocks here. I've got Cisco's properties, the pet's properties, the pet prototype's properties, and then the object prototype's properties. Yeah.
I missed something, but you create Cisco for the prototype.
Cisco gets it. That's exactly what happened here. Yeah. When you change the prototype, Cisco is always looking at the current prototype, not the prototype as it was at the time that I created Cisco. It's driving me crazy. Okay. I can also make functions on the prototype. So I'm going to do, I'm going to copy and paste this one. So pet.prototype, that was a bummer. Okay. Pet.prototype.speak equals this function, console log I'm whatever my name is, the whatever my species is. The this here refers to whatever calls the method. So if I do Cisco.speak, it says I'm Cisco the cat. It pulled those properties from Cisco. So let me ask you, and this is a pretty subtle question, but I think it's an interesting one. Why is it better to define this function as a pet.prototype function rather than putting it in the constructor function? Because I totally could have put it in the constructor function. I could say, I could make my constructor function be you know, whatever, name, age, species, and I could make it just another property. Etc. Why is it better to do it the other way by attaching it to the prototype than doing it in the constructor function? Yeah, so say that second part again because I didn't hear it. I was too happy about your first part. Yeah, exactly. So what Celeste said is because when you do pet.prototype.speak, you have one function that all the pets are sharing. Whereas this, the constructor would actually make a new function for every pet. It's wasteful. And if you ever want to change speak, you would have to change it for every pet. Whereas if we have it in the prototype, you change it just once. Because every time this constructor function runs, it's going to create a new function. Speak is going to be a has own property for your pets. And each of them is going to have their own special copy of the speak function. If you do it this way, if you do it in the constructor. If you do it with the prototype, Now I'm just declaring this function once. This function exists once, and all of the pets inherit it, rather than each pet having its own individual function. Think about it, Kelsey. Ask me questions later. Prototype methods. Do you guys remember that we talked, I just want to mention this, I don't have a slide for it. Do you remember that we talked about one of the difference between arrow functions is how it deals with this? Yes, right. It does make it weird in Mocha and Chai. It also makes it weird here. If I, let me just do something, if I say pet.prototype dot say name, or just even get name, is a function that just returns this dot name. Beautiful, compact, wonderful. However, this doesn't work the way you expect. Oh, Cisco's name isn't undefined. What are you talking about? Whereas if I redefine it as not an arrow function, now it works. So just something to note, that arrow functions behave differently with regards to this than non-arrow functions. Sometimes that's a good thing, but make sure that you know how this is going to behave and that you're doing it deliberately. I'll tell you when you're older. No, I don't have a good understanding of that yet, Celeste, so I don't know. The question was, what is the this in the arrow function? It has to do with like some context stuff, but I don't have a good answer for you, but I'm sure MDN does. Other questions? All right. There's other inheritance syntax that JavaScript uses. We talked about constructor functions that we can use for inheritance. We can also use this create. So, and I have a comment here because I find this syntax a little confusing. So if I make a cat and its species is cat, it's just an object, right? If we did a dot dunder proto, it would just be an object. Now if I do Cisco and I make Cisco an object dot create cat, basically what I'm saying is I want Cisco to be a cat and then some. And Cisco's proto now is going to be cat. So let's look at this. So here's cat, proto, just an object. And if I do cat tab, I see that it has its own property species and then it just inherits everything else from object. And now I want to make Cisco, this is another one of those prototype functions, Brittany, where I'm using object dot instead of like cat dot. So I'm doing object dot create cat. That means that I want Cisco to inherit from cat. I want Cisco's prototype chain to be cat and then object. Cisco has a species. I can also give Cisco a name. Now the name is an owned property. The species is coming from cat, which is one back in the prototypical inheritance chain. And then the everything else is coming from object. A way to build objects on top of other objects, or data types on top of other data. And then at some point, I think it was in ES 2015, JavaScript decided to give us more class-like syntax. This, if you've used Java, if you've used Python, I'm assuming this is what it looks like in Ruby too, though I haven't used Ruby. This is more traditional object-oriented syntax, where you are actually creating classes. You're not making constructor functions. So this, have you guys heard syntactic sugar before? Yeah. No, what's one typo? Oh. It's because it's usually an X, and my brain just couldn't handle it. Okay. Syntactic sugar. So have you guys heard that before? Yeah, Bree, what is it?
I mean, I've heard it used in phrases when it comes to like, oh, how JavaScript made this syntax a lot simpler and a lot easier to implement. It's like, at least that's when I've heard it used.
Yeah, it doesn't give you any additional functionality.
Yeah.
It's not like it's giving you new functionality, but it might make your code look nicer. It might be easier to use. Yeah. So we're not getting any additional functionality out of this. It's not changing it so that it's using class-based object orientation versus prototype-based object orientation. We're still using this prototype. But it's nicer for people who are used to writing classes. So I make a class and I give it a constructor. Somebody's angry back there. All right, I'm not sure it's going to let me do this because I think I might have given a const. Yeah, pet has already been declared. So let's try that again, and I'm going to let's see. Really? All right, hold on. I just don't want to, in case I want other things. So I'm going to make this pet2. Okay, so now I have pet2. Notice pet2 is still a function, even though I like to think of it as a class. And, all right, and so now I can now make Rufus. Syntax is the same. How old is Rufus?
Wow. That is a lie. That is a lie.
40? Oh. Poor Rufus. Okay. Well, we're gonna go back in time, and Rufus is gonna be 4 years old. Okay, so there's Rufus. If you look at Rufus's inheritance, Rufus has its own properties. Pet is actually contributing nothing to Rufus right now, and we have all the object stuff. So similar, like the functionality is the same, but it looks more like what people who are used to working with classes look like. And you just give it a constructor function. And now instead of having to do an object.create, I can do subclasses using this extends. So now class cat extends pet, meaning I want cat to have everything pet has, but I want its constructor to just have name and age, because I can tell you what species cat is. This super means run the constructor of my parent, or ancestor probably, if my parent doesn't happen to have a constructor, and just feed it cat. So now if I want to say kitty, and I didn't know how old kitty was, so I made kitty 8. I didn't have to tell it that kitty was a cat. I just made a new cat, and then species cat got filled in for me automatically. What if I do kitty? What's that going to be? Then pet. And actually, because I've been reusing pet has like speak and get name and all of that from before. And then I probably meant to put pet 2, extends pet 2 here, because actually now it's just extending this old pet that we had. But like I said, they're both the same, because the class is just syntactic sugar. They're both the same. They both have the same underworkings.
Yes. Kitty's own properties besides 8 and 6.
No.
It's just the most recent.
So yeah, so kitty doesn't have, the only way you can get to cat from kitty is by looking at the prototype. Kitty doesn't have an actual property called cat. Am I answering your question, or?
Oh yeah, well, your answer to the one I asked, but what I meant.
Yeah.
Species. So species is.
Kitty species is its own property, because when we look at pet 2, the constructor is assigning the species to the instance. Those are from pet. Yeah. And right now we don't have any, cat doesn't have any of its own properties, but I could say cat.prototype.speak equals function meow. It's interesting. Oh, right. Thank you. Good catch, Kelsey. And this actually, we saw this before. I may have glossed over it a little bit, but when you do property shadowing, which is basically what I'm doing, I'm property shadowing speak for cat over the speak for pet. When you do property shadowing, it doesn't seem to like register it. Node, I think this is just a shortcoming of Node. Node doesn't seem to register it in this handy like tab, show me what you got thing. That's just a problem of Node, or a quirk. Okay. Cool. All right, so resources. This was a pretty dense lecture. It's probably the densest one that we've had so far. If you want to look more at, or if you want to learn more about prototypical inheritance, this lecture was basically written by me, like scouring the JavaScript or the MDN prototypical inheritance page. And then I also found this nice. This is a lesson from javascript.info. So sometimes just hearing it in different words or hearing it phrased differently helps. And so here we have, so this is talking about, look, it's like rabbit. So if you have an animal, it eats, and if it's a rabbit, it both eats and jumps. And anyway, and this is doing prototypical inheritance by actually like literally assigning .proto. So it does things a little bit differently. And then one nice thing about this is that it has these exercises, or what it calls tasks. So you can sort of quiz yourself if that's something that you'd like to do. All right, cool. You all look really beat. It's kind of an intellectually demanding lecture. All right, great. And I'm even gonna give Justin 2 minutes to set up before the next lecture.